Greetings everyone, Patrick here with Patriot LLC. Patriot is a platform for those who have the yearning to learn, grow, and be empowered by embracing sustainable solutions and practices in their daily lives. Today we have an exciting video. We're going to focus on the home, starting with what is a sustainable home. When we think of a sustainable home, we must imagine a home that will provide shelter, resources, and longevity. A home that provides comfort, good indoor air quality, and a healthy environment. We want our home and our building to work for us, to be self-sustaining, to create the energy and resources required to sustain the needs of the occupants and the systems within the building. The design discussed today in this video are not just for homes, but should be utilized for all types of buildings, residential, commercial, retail, etc. Because right now, real estate is in a position to lead the charge against global warming. To do that, we need to reevaluate how we design and build. We need to put function over fashion and build for the future by incorporating reliability, resiliency, and redundancy into our design. These design concepts will require a change in our current preconceived notion of what a home looks like. The issue is, builders build what homeowners want, and homeowners buy what builders build. We need to break that cycle. Long gone are the home designs with multiple hips, valleys, multiple roof angles, dormers, and useless attics. The design needs to be fit for purpose. Let's look at an example. Okay, here we are looking at a net zero energy home. In this presentation, I will be speaking about my mantra, fit for purpose. Fit for purpose meaning that you design for a purpose. Whatever you design, incorporate into your design has a purpose, hopefully multiple purposes, as we will speak to. The design process called reverse engineering, meaning we design from the top down. This is important in many ways, which we will discuss. This home is a passive solar net zero energy home. A net zero energy home produces as much energy as it consumes on an annual basis. Remember I said the home needs to be self-sustaining to create the energy and resources required to sustain the needs of the occupants and the systems within the building? This design incorporates systems that complement each other, providing a synergy that leverages reliability, resiliency, and redundancy. This is a multi-generation home, which perhaps may be the future of home building, as it has become apparent in how difficult it is for younger generations to afford home ownership or even afford to rent. So let's jump into it. The home I am showing you today is a home I designed and physically built. It is an example of what is involved when designing a sustainable home. I am not saying that every home should look like this. On the contrary, you would design your home based on a topographical area in which the home would sit. Understand what would influence the home's operation. Example, the terrain, trees around the building, trees around the home, other buildings, and the orientation, to name a few. The first step would be to do and perform a site analysis to identify fit for purpose. All right, let's discuss the building envelope. Let's start with the roof because, as I mentioned, we design from the roof down, reverse engineering. We start with a metal roof chosen for its longevity, 50 years plus. The metal used is sometimes manufactured from recycled metal, but at the end of its life, it can be recycled. The south-facing roof should use a standing seam metal profile. The color of the metal matters, right? Because the color we utilize here is almond. The color almond has a solar reflective index of 0.77, the highest rating for a metal roof, and an emissivity of 0.83. Solar reflective index measures the roof's ability to reject solar heat. Solar reflectance is a measure of the amount of solar radiation reflected into space, and thermal emissivity is the relative ability of a roof surface to release the absorbed heat, defined such that a standard black roof has a reflectance of 0.05 and an emittance of 0. So a standard white roof has a reflectance of 0.80 and emittance of 0.90. So the almond color is right below a white roof. I don't think you want a white roof on your house. So definitely the color almond is one of the main reasons we utilize that color. I mean, the reflectivity, emissivity of that color is fit for purpose. All right, so why is this important? Well, in the summer months, the sun can impose a huge thermal heat gain on the home. Heat absorbed by the roof will emanate through the roof into the attic, creating a thermal load. That is transferred to the occupied space, requiring the need for larger AC equipment and longer run times. So the color of the roof matters a lot. In this case, the color of the roof dictated the colors of the rest of the home. All right, so you have to complement, of course, the color of the roof. Match the roof color. So basically, all our fascias are metal clad as well to match the color of the roof and provide longevity, protecting the fascias. The porch dimensions, we'll move on to the porch, the front of the house. The porch dimensions are 48 by 8. The porch is steel framed with concrete base over it. We utilize corrugated steel and pour concrete on top of it. The front stairs are constructed of galvanized steel with baked on enamel paint. The choice of materials for the porch and stairs is based on material longevity and reduced maintenance, as opposed to utilizing wood framing, which would require periodic reapplication of a wood preserver or staining and replacement within 10 years. So the utilization of steel and concrete has a longevity purpose. I understand it has high carbon, embedded carbon, embodied carbon. I understand that. Hopefully, we will come up with concrete which replace with the conventional concrete we have right now, utilizing green concrete. There's still a maintenance issue, right? So we're still looking at pressure washing the house, and that's all required for the porch area. All right, let's talk about fenestrations within the building envelope. Fenestrations is another term for openings within the building envelope. The windows, all the windows are operable. They're casement style windows with low E double pane on the east, west, and north side. The south side, we did not use low E, the double pane, but we did not use low E because we want the solar gain. Because this is a passive solar home, right? They're argon filled. They're builder's grade vinyl windows. Casement windows are preferred because they have a closed tight locking mechanism preventing air leakage. So the windows on the east and west orientation, as you see, have a smaller dimension to reduce thermal sun load. The doors, the R value varies on the doors. There are a few manufacturers of patio doors we use on this application. I found that the patio double doors have some air leakage. So I would strongly recommend you do not skimp on quality when it comes to doors and windows. We had to replace some windows and doors in this home because of the seals between the glass were compromised. I want to point out that if you build yourself a high performance home and you make the home airtight with, let's say, an air change in our ACH of a range of 0.2 to 0.6 air changes an hour, you have a high chance of putting the home under a constant negative pressure. This may contribute to the seals on the windows leaking. I see this both in a residential and commercial situation. The windows on the north side set way up high are called clearance story windows. They provide two things fit for purpose: daylighting, providing additional natural light early in the morning and late afternoon to augment the need for artificial lighting. They also are operable windows, and when open along with doors open on the first floor, create a Venturi effect, providing passive cooling throughout the house. Again, fit for purpose. Okay, so this is a south-facing roof. It's a standing seam. And why do we use a standing seam on a south-facing roof? Well, at least in the northern hemisphere, right? The standing seam is part of a system when attaching PV/solar thermal panels to the roof in combination with an S5 clamp or other manufacturer of a standing seam clamp. Let me show you what that would look like. So this would be part of a system, right? So this right here, this portion right here would actually sit on the standing seam. And this portion right here will clamp down on your panel, solar panel, and whether your PV panel or your solar thermal hot water panel. Clamp down on the panel. It's attached to this clamp and clamp down on your standing seam. So you don't need to install a solar panel rail to support the panels as you would with the installation on a conventional roof. So fit for purpose. The clamps are attached to a myriad of other components to the roof as well. So as you can see, a ladder was constructed of unistrut to provide the ease of access to the panels as well as electrical wiring. So fit for purpose. Commercial grade roof hatch was also installed for the easy access to the roof system. In this case, because the roof is so high off the ground, it wasn't permissible or safe to utilize an extension ladder. So we incorporated a commercial grade roof hatch, which turned out to be one of the best things we've ever done as far as access to the roof. And also for safety, and should there be a fire as well, allow emergency access to the roof. Looking at the house from the south side, we want to look at the solar gain. Now, what we see here is the design is critical. The key to a passive solar design is accommodating the right amount of glazing windows on the south side of the house to passively heat the house in the cooler months and not overheat the house in the summer. Positioning the windows is critical. Also having the correct roof overhang to prevent the high-noon summer sun from coming in through the windows in the mid-summer months is necessary. As pictured over the windows here, the shading, this picture is taken high noon, December 21st. As you can see, the shading is at the top of the windows, allowing maximum solar heat gain in the winter months, in the cooler months. You can also see some patio doors have what's called Juliets or mock balconies, another term that they use. So in this case, we made provisions for a porch. The porch has not been built, it's optional, but what we did was we had to provide some safety for those patio doors. So you can call them a mock balcony or a Juliet. I think you prefer to call them Juliets, right? Alright, so both floors are concrete. The first floor being having a 4-inch concrete lift with 2-inch styrofoam board under the slab, providing an R10 insulation value. The second floor has a 3-inch concrete lift over the wood sheathing decking and has an R19 bat insulation in between the first floor ceiling and the second floor. Both floors have radiant heating PEX tubing embedded in the concrete. So as is pictured here, the solar thermal sun, the sun comes in, passive solar comes in, it heats the slab on sunny days, the heat is transmitted to the radiant tubing. And with the radiant heating circulator on, the heat from the south side of the house is transferred to other areas of the home not exposed to the south side of the house. Right? Fit for purpose. Radiant heating is the most economical and comfortable heating there is. And the use of concrete as your mass is the most economical, efficient way to use radiant heating. Once the slab is heated up, it takes very little additional heat input to maintain the floor temperature. I will be covering more about the benefits of radiant heating and the mechanical electrical systems in other videos. So be sure to check them out. Picture here are two water source heat pumps situated over two hot water thermal storage tanks. Both water source heat pumps, often referred to as geothermal systems, they share the same closed ground loop system, a closed loop system. In this case, the ground loop is horizontal as opposed to a vertical ground loop. The solar thermal hot water panels on the roof, 3 4x8 panels, will provide heat to both tanks when the sun is out and active. The heat pump on the left is a water-to-water heat pump. This unit provides water heating for both the radiant and domestic hot water thermal storage tanks that are below it. Both tanks have an electric element as a backup to the solar thermal and the heat pumps. So you have 3 ways of heating the water in the thermal storage tanks. First will be the solar thermal hot water. Second will be the water-to-water heat pump. And third will be the electric elements in the tanks themselves. So you have some redundancy, right? To always have hot water for both your radiant heating for heating and also your domestic hot water. So the tank on the right is your domestic hot water tank. Again, that is heated both by the solar thermal hot water and the geothermal water-to-water and the electric element. The tank on the left has a capacity of 120 gallons. You need a lot of storage. I would request that we have a lot of storage in this case for the radiant heating because we have 2 floors we're trying to heat. The tank on the right is an 80-gallon capacity, and that's used for your domestic hot water. So up above, like I said, we have the 2 water source heat pumps. The one on the left is your water-to-water heat pump. The one on the right is a split system. It's what we can call the condenser. It holds the compressor, and it is a split system water source heat pump. So the air handler is actually in a loft on the 2nd floor. So we have 2 types of heat. We have the radiant heating, which I like to use in preferable that is used as your primary heat. And then you have the split system, the water source HVAC split system, which consists of both a split system, condenser, air handler, and conventional ductwork. In our case, we use spiral ductwork, which we will talk about later in a future video, why and how efficient spiral ductwork. Ductwork is the key. Ductwork makes all the difference in your HVAC system, and we will discuss that in future videos. All right, so what we see here is a portion of the mechanical electrical communication room. In the corner, sitting above the electrical trough, and we see mounted on the wall a Solarc inverter. Solarc is a inverter, one of the best inverters on the market. It's called the Swiss Army knife of inverters. I've had no issues with this inverter for the last 2 years. Very supportive of the help I get from Solarc when I need to address any upgrades, updates, firmware updates. They're great. We have visibility to the inverter at all times, whether you're utilizing your cell phone or your iPad. You can see what's happening with the inverter, your electrical consumption, electrical use. So great inverter. So on the left of that, sitting on the floor, We have a lithium-ion battery. This lithium-ion battery is manufactured by Fortress. It's called the eVolt battery, and it is a 18.5 kW battery, 370 amp hours availability with an 80 amp maximum output. The battery has a building management system. It has a battery management system. The battery management system that monitors the charging and discharging of the battery, optimizing the performance and longevity of the battery. Together, this system provides over 2/3 of the home power consumption, which makes it a net zero energy home. The combination of a solar PV and a battery is key to having a net zero energy home. So the technology for solar PV with battery backup has come a long way, and so have the national electric codes. So the key is, if I was to install the same system today, the equipment would have to be placed outside the house, as the new electric and fire codes dictate stringent codes that make it almost difficult, not practical, financially practical, to install inside without providing a dedicated room for the battery. Yep, that's where we are right now. Therefore, I see homes in the future, home building right now, would have to provide an attached or detached room to accommodate the solar inverter and batteries. Something to think about when designing a home. All right, so I will cover each of the systems mentioned today in a separate video. We will have a more in-depth conversation about the installation and operations of each system. So to summarize, a high-performance net zero home does not have to look like this one, but the design of the home and or building should be able to accommodate the systems we discussed in this video in order to achieve net zero. The systems would have to have synergy and work together. And this would require some strategic thinking. Remember, fit for purpose. If the high performance home is something important to you and you have multiple projects and would like some consulting on, let me know and I'll be happy to assist you. I will be providing more videos on information regarding energy and sustainability in general to help you become self-reliant, sustainable, and more knowledgeable. So thank you for viewing this video. Please hit the like, share, and subscribe buttons. And remember, we are to survive on this planet with finite resources. We're going to have to adapt to changes, starting with the built environment. Practicing sustainability in our daily lives will preserve the future of generations to come. To find out more, join Earth Patriot as an Earth Patriot loyalist. Visit the website earthpatriot.com and or email us at earthpatriot.com. Email us at earthpatriot.com. So thanks for watching, and we'll see you on the next video. Until then, stay Earth Patriot strong. Thank you.